So we have another example here which is going to cover KVL and KCL. We're actually going to use both of them in this problem here as well as Ohm's law. This problem is asking us just to find what Vy is. So in order to figure out what Vy is, we need to know some things here. Like we could write a simple loop here. Let's just go ahead and do this loop here right now. That would give us an equation for finding Vy. If I did a loop right here like this, now there's other loops we could do. I'm not saying that this is the only loop we could do. In fact, we could show you a different one maybe in a little bit here. I would get the equation when I'm coming into the negative side of that 25 volt power supply. So minus 25 plus I'm going to write here voltage across the 500 ohm resistor. I don't know what that is. Plus Vy, which is of course what I'm looking for, plus the voltage across the 200 ohm resistor. And that's all equal to 0. And of course we see the problem right away here is that I have an equation here that's absolutely correct, but there's three things I don't know in this equation. So we're going to definitely want to write some other equations to find out additional information. So one thing we might say is like, okay, well, let's look at another loop here. And another loop we might want to look at here, which would kind of be a somewhat reasonable loop to look at, would be this other loop inside here. And so if I look at that loop, I would get an equation of coming in on the negative side, negative 15.2 plus the voltage across the 10k ohm resistor plus 0.8 volts plus the voltage across this 200 ohm resistor again. And this is equal to 0. Now, this equation, I'm sorry, this shouldn't be a plus. I always joke that if I was in class in a regular lecture hall, you guys would have all caught that. It's a negative here because my arrow is hitting the negative side of the power supply, so that means I'm minus whatever the value is. So I'm minus 0.8 volts. And again, we could simplify this a tiny bit, and I'd wind up with minus 16 plus V of the 10k ohm resistor plus V of the 200 ohm resistor equals 0. Now this equation doesn't have what we're looking for. It doesn't have Vy in it. And the other thing is I've actually introduced another unknown variable, 10k, and I've got another variable here, V200. Well, no, that is in the other equation here. So it looks like these loops equations aren't actually helping me at all. But this is where sometimes we just have to write a bunch of equations down in order to kind of make progress here. What I'm demonstrating is that some of these problems are trial and error, and sometimes these equations, it's not necessarily that I want to erase them because, well, they're not going to be useful. They might be useful to me at a later point, but currently they're not that useful to me. So we have to kind of think of some other things we could do here. Well, one thing we should first right away notice here is that there's this current I beta that's labeled here, and then that's this dependent current source right here. So one way you can think of I beta, I mean, it's just this arrow here, but I'm also going to draw here that, well, using Ohm's law, I beta is going to be the voltage across the 10k ohm resistor divided by 10 kilo ohms. That's what the I beta is going to be. So if I could figure out what this voltage is, I could figure out this current, which then I could figure out what this current is over here. All right, so let's kind of try and see if I could maybe figure out what I beta is. Well, we can quickly see from this equation here, if I rearrange, I could rewrite this with Ohm's law as V10k is equal to I beta times 10 kilo ohms. Now, we said, oh wait, if I find I beta, I can get a lot of useful information for myself here, which is true. So I want to look here is that, well, I could look at this right here, and I could substitute it back into this equation. So I have minus 16 plus I beta times 10 kilo ohms plus V200 ohms equals 0. Now it looks like I haven't made any progress because all I've done now at this point is like, okay, well I've changed things around, but I still have two unknown variables here, and I haven't made any progress. But now let's examine this V200 a little bit closer. And I'm going to actually draw a dot here for a node. And if I look here, I'm going to look at the fact that what do I have coming into this node? Well, this current, I need to follow it along. This current I beta is entering the node. So I have I beta, that's right there. And then also, if I look here carefully, I have 29 I beta that is entering the node as well. Well, I know whatever's entering the node has to be what's leaving the node. So if I go down here, I have to have, well, I beta and 29 I betas coming in. So the current, put it off to the side here, current through the 200 ohm resistor is I beta plus 29 I beta, which of course is just 30 I beta. Now we've actually made some really good progress here, because again, using Ohm's law, I could write the equation that the voltage of the 200 ohm resistor is equal to, well, the current going through it is 30 I beta times the resistance is 200. So again, I want to emphasize here, this 30 I beta, this is the current that's going through it. And we found that by using KCL, because the current entering that node has to be the current leaving the node. And now I can go back and further substitute in. So I'm going to substitute this in to here, and I wind up with minus 16 plus I beta times 10k, and then it would be plus I beta, and if I do the 30 times 20, I'm sorry, 30 times 200, and put it in engineering notation, this would be I beta times 6k, which is equal to 0. Now notice here, I now have one equation with one unknown. Now it doesn't give me what I'm looking for. It doesn't give me this Vy, which is what I'm looking for, but it's giving me more information about the circuit. I'm starting to now be able to get some information about the circuit. I'm able to find a current. And once you're able to find something like a current or a voltage of just even one circuit element, that's a good news, because then we can usually start getting more information about other circuit components. So just simplifying this here, we get that 16 kilo ohms times I beta is equal to 16 volts, and doing this, you would get that I beta is 1 milliamp. And again, when you do the divisions, make sure that you realize that when you're doing 16 kilo ohms, that's the same thing as 16,000 ohms, or you can just do 6 times 10 to the third in your calculator. Just make sure you're aware that you go to milliamps. All right, so we have that I beta is 1 milliamp. So I'm going to go back up here. And there's a lot of things here. I'm going to erase a couple things here, these just to clean up the diagram a tiny bit, so that we can kind of have here. So I beta, I'm going to change that because I now know that this is 1 milliamp. So that's 1 milliamp that's flowing in here. That also means that I know that this current is now 29 milliamps. So I have 29 milliamps flowing this direction. Now, that also means I have 29 milliamps going through that 500 ohm resistor. Now, I also now have, using KCL, if I look at this green node again here, I have 1 milliamp coming in, 29 milliamps coming in, and then coming down here, I would have 30 milliamps. Now, you might say, okay, well, that hasn't given me a lot of information. I still don't have what Vy is. Well, believe it or not, now we have all the information we need to use this original equation that we said wasn't very useful to us to find out what IV is, or Vy is, I'm sorry. So let me rewrite that equation down here for us. So we've got negative 25 plus V 500 ohm plus Vy plus V 200 ohm is equal to 0. But now this is where we're going to use Ohm's law, because I know Ohm's law that V of the 500 ohm resistor is just the current that goes through the 500 ohm resistor times 500 ohms. But going back to my circuit diagram, I now know what the current going through the 500 ohm resistor is. It's 29 milliamps. So this would just be, whoops, my hand hit a bunch of things there. This would just simply be 29 milliamps times 500. Now again, make sure you use your engineering notation correctly to get the correct voltage here. This would be 14.5 volts because it's 29 milliamps times 500. Similarly, we can get the voltage for the 200 ohm resistor, because we know it's the current through the 200 ohm resistor times 200, which that is going to be 30 milliamps times 200, which is oh, I did my computation wrong there, which is 6 volts. Okay, so now the one thing I should have emphasized here, we're okay, but remember that original loop I drew was with the arrow going that direction. So the currents all need to match that direction, and the 29 milliamps is in the same direction, and the 30 milliamps is in the same direction, because this equation we wrote was with the currents all flowing counterclockwise. If we had done it clockwise, those would be negative values, which obviously is going to affect the voltages. But now we're fine with that, and we simply just plug into this equation here. So I get negative 25 plus 14.5 plus Vy plus 6 equals 0. And then now just some basic, obviously, arithmetic. And we get that Vy is 4.5 volts as my final answer. Okay, so this is the last example I'm going to do with using KVL and KCL. I wanted to do some more challenging ones than we had done in the videos where we introduced these concepts, but these are now all we're going to do, and we're going to move on to additional things. And actually the next topic we're going to be covering is series and parallel resistors or components. All right?